So let us move on for fourth module where we have principle of inclusion, exclusion, one topic, dearrangements, another topic, and Rook polynomial in the first half. Second half we have this recursive relation, first, second order. Okay, first order linear, second order linear, then recursive relation with constant coefficients. It's not that difficult, very simple topic. Then principle of counting. So here we are going to recall few things. That is the formula of A union B. Mod of A union B is nothing but mod A plus mod B minus A intersection B. This we had seen in the second module, beginning topic. I don't know whether it was second module or third module, where sets are there now in that module. Okay, then A complement intersection B complement is equals to A union B the whole complement, and A union B the whole complement mod of A union B whole complement is nothing but S minus A union B. So if you find mod of A and B, this mod S is nothing but the total number of all the possible permutation. A union B combines the terms which are not there in A union B, except all the terms which are not in A union B that I have to find. So S minus the terms in A union B will give me all the terms which are not there in this term. That's it. Then A complement intersection B complement whole mod is equals to A union B the whole mod. Same thing is which is equals to S minus mod of A and B. So I can, instead of minus mod of A and B, I can expand this as this much. Okay, like this I can expand this. A mod A minus mod B plus A intersection B, like that. Okay. So equation one is called the principle of inclusion exclusion for two sets. So now principle of exclusion. Suppose we have n number of sets, then it will be simple. First, what I'll do, S minus AI plus summation of AI intersection AJ minus summation of AI intersection AJ intersection AK plus so on up to minus 1 to the power of n. This we have seen that. Now this is the main thing in that model paper. When I solved the question, I was like confused, like how those things comes. That comes because of these principles. Okay, if they have given satisfying exactly some numbers at most, or not at most, exactly some numbers they have given, then the formula will be like this: em is equals to sm minus, suppose I had to find like at least two will repeat, so it will be e of 2 is equals to, it will start from s2 minus 2 plus 1, that is 3 by 1 into sm plus 1 into s3. Okay, like suppose they are taking, so s2 minus 3 by 1 into what to say s3 plus what is it 3 also, so 4 by 2, 4 to s4, then 5 to 5 3 s5, like that, so on it will go on up to sn. Okay, same way if they have given at least like that conditions. Okay, so for at least condition, how it will be, whatever the L of m is equals to least Lm is equals to Sm minus m by m minus 1 first. So here I suppose I took 2, so S2 minus 2 1 into S3, then 3 2 into S4, like that. Okay, when I see that question, I think you will be able to understand it aram se. You won't be having any problem if I once solve a problem. Okay, so now here the same thing they are saying, let S0 is equals to S and S1 is equals to summation of AI, S2 is equals to like this, like that, so on, so on. Now ignore that. Now let us move on for what to say mm, further questions and all. Just a moment. Just skip for a few seconds. Okay, I was just texting. Okay, sorry for that. I cannot pause in this laptop. I have to just finish, completely stop it, and then I have to do like that. Model question paper, and I was just sharing the link of this video for my friends in the group. Okay, so now they're saying among the students in a hostel, 12. Okay, among the students, so many students, like some number of students are there. Okay, in that what, 12 students study max. How many for max? 12 students. 20 study for physics. 12 for max, 20 for physics, 20 for chemistry, and 8 for biology. So this is nothing but A1, A2 is it, right? So A3. Okay, this mod A1 value is 12, mod A2 value is 20, mod A3 value is 20, mod A4 value is 8, like that. Then there are 5 students who study for A intersection B. Then there are 7 students for A intersection C, 4 students for A intersection D, 16 students for B intersection C, 4 students for B intersection D, 3 students for, like this. Okay, I understand, right? So this is nothing but AI intersection AJ mod of those values we have here. Then here see A, B, and C. 3 students for A intersection B intersection C. 2 students for A intersection B intersection D. 2 students for B intersection C intersection D. And 3 students for A intersection C intersection D. So all the positives of AI intersection AJ intersection AK. Then finally 2 students for all A intersection B intersection C intersection D intersection. So one by one I will write off. See here, individual only one subjects I have this. So this whole thing if I add, let me write this as S1. Then A intersection B is equals to 5. So see here till here, this thing is right down. Let this be S2, and except for this, yeah, this part be S3. This will be my S4. Okay. Now I have to see A complement intersection B complement intersection C complement intersection D complement intersection. So 71. Okay. How this is 71 is nothing but 12 plus 20 plus 20, 20, 40, 50, 60. Okay. Then okay, I think in question itself it is mentioned of this. Further, there are 71 students who do not study any of the subject. From there we got this A intersection, B intersection, C intersection, D intersection. So to find S, where S is the set of all students in the hostel, we have A intersection, A complement intersection, B complement intersection, C complement intersection, D complement is equals to A union, B union, C union, D union, the whole complement, which is nothing but mod S minus this thing, A union, B union, C union, D union. That's it. Okay. Now we have this thing. This thing is nothing but this whole thing. See here, this whole thing is nothing but my A union, B union, C union, D union. Okay. Now S I don't know, but this value I know. So 71 is equals to mod S minus. So I can simply write off mod S minus S1 plus S2 minus S3 plus S4. This thing I can find whatever the value I am getting. I will keep it as it is. Then what I will do, I will send that value to the left hand side such that, okay, so this whole value I am getting as minus 29. Okay, if you add all these values, not add minus subtract this, add S2. See here I said minus S1 plus S2 minus S3 plus S4. If you do, you will get minus 29. So if you send mod S minus 29 is equals to 71. So mod S is equals to 71. Send this 29 minus 29, so it will become plus 29. It will go to, that is nothing but 100. Therefore, I get that mod S is equals to 100. Total number of students in the hostel is 100. Simple, right? You understand how they get that. From the same above example, now what it is saying? It is asking to find exactly one subject. How many students will study exactly one subject? So exactly one means that first formula you saw here, right? You can see here like this. So exactly one means from E1 I will take. So if I'm taking E1, so from S1 minus 1 plus 1, 2, 1, then 3, 1, 4, 1, again I can decide aramse like that. So now see here, they have exactly one subject. So what will happen? So S1 minus, here 1 is means here 1 plus 1, 2, down 1 will be there. Okay, into S2. Then plus 2 is there, just write 3 here, down 4 will come here, S3 minus S4. How here 4 will be there, here 3 should come, right? Here it was 1, So here it will be 3, it will be 2 here, sorry. If it is 4 here, it will be down 3 here, like that. Uh, we have to then, okay, and here E of 1 is equals to. So substitute the value. This 2 and down 1 is nothing but 2C1. Then 3, 2 is nothing but 3C2. Then 4 is nothing but 4C3, like that. Find the values and write off. So you can do the same for exactly one subject, exactly two subjects, exactly three subjects, then at least one subject. If I show you for at least one, you can understand for remaining thing. For at least one, what is happening. Here I see here LM we will take for that. Suppose at least one. So L1 is equals to S1 minus M divided by M minus 1. So 1, 0, 1, 0. Then into S2 will come here. Okay, then here it will be 1 and here it will be what to say 0 itself. Yeah, I think so. 0 itself. That's how it will work. Lm is equals to m. So if at least one means s1 minus 1 to 0. So 1c1, 1c0, 2c0, 3c0, so on like that. 4c0 will be there into s2 plus s3 minus like that. Okay, same thing. If you do so, see here for L1, S1 minus 1 0, S2 plus S2 0 2 0. You understood, right? Then I don't think further things are required. Like that itself, even for this thing you see once, you can solve that by your own. Determine the positive integers 1 less than n less than 100 such that n is not divisible by 2, 3, 5. N is, so this is one important question which has occurred in model paper, I presume somewhere. I think it has occurred. Very interesting and important question. Okay, so now see here what they have given. First, I have to find n is not divisible by 2, 3, or 5. Then n is divisible by at least two of these two numbers. And then n is divisible by exactly 2, at least 2 and exactly 2. So now let us say s is equals to 1 to 100. So positive number from s to s is equals to 100. S, which means s naught is 100. Okay, let A be a set which is divisible by 2, B be a set divisible by 3, and C be a set which is divisible by 4. So what I will do, it is divisible by 2. So I have to just divide 100 by 2, 100 by 3, 100 by 5. That is my A, mod A, mod B, mod C. You can see here, right? Now what I have to do, done. My AI is done, A of I. Now I have to find for A of I intersection A of J. Then I will have to find A of I intersection A of J intersection A of K. Ignore the handwriting because I cannot draw properly from mouse. So you understood how I got mod A, mod B, mod C, right? Now then what I have to do, then I have to find for A intersection B. I will take A intersection B, A intersection C, then B intersection C. That's it. Three things will come. So how I will do that? Number of elements which is divisible by both 2 and 3. So I will take, I will multiply, that's it. So that is nothing but 100 divided by 2 into 3. So you can do like this, right? 50 by 3 also you can take. What if you get the answer, it is nothing but 16.66. Ignore the point, just take the whole number. Okay, that's what you have to do here. Similarly, if I have to take A intersection, what is that? C, divisible by both 2 and 5 will be there. So the denominator will become 10. So B intersection C, denominator will be both 3 and 5. So 3 into 5. 100 by 2 into 6. Let me just write like this: 2 into 6, 2 into 5, 3 into 5. Then I have to find what to say. Okay, now if I add these three numbers, that is my S2. Okay, and if I add this three number, that is my S1. S1. Then at the end, what I have to do, I have to find all three, which is divided by all three. That is nothing but 2 into 3 into 5. Whatever the answer I get, that is my S3. See here, I have written here. So I'm adding here, so I can see, you can see here my S2 is 32, my S3 is 3, and my S1 is 103. So first I can say that simple thing, n is not divisible by 2, 3, or so. Determine the number of positive integers. Okay, first thing, let us solve the first question. Now we will be solving first question. So for to find A intersection B, A complement intersection B complement intersection C complement, that is A union B union C, the whole complement. So first I have to find A union B union C. then I will take complement. So if I take complement, that is nothing but mod S minus uh, A union B union C, which is nothing but mod S minus S1 plus S2 minus S3, that you will do. Okay, so if you do that here, S minus here S1 plus S2 minus S3, you got the value that is your which is not divisible by 26, which are divisible by 26. If you have to take, then you will simply add S1 plus S2 minus like that, you will just add that S1 minus like that. Okay, then therefore number of the integers 1 less than equals to n less than equal to 100 not divisible by 2 3 5 is 26. How you got 26? You have to take complement, okay, which is divisible by 26. You will simply take and add all these things. Okay, I mean which is divisible by 2 3 and 5, total all the set of numbers, that is nothing but A union B union C, which is nothing but mod of AI minus mod of Aij plus mod of AI AI, what is that, IJK, like something like that. Now then they have said least. So what they have said, least two of the numbers from this, or among these three numbers, any two I have to take. So L2 I have to do. So L2 means S of 2 minus, then here 2 1 m by m minus 1. Then keep on increasing only the numerator, not the denominator for L. So S2 minus 2 1 of S3. I don't have anything else over here, or else I would have written plus. It will be like 3 1 S4, but I don't have this thing, so this won't be there. I have to just write S2 is what, write the value minus 2 C1 is nothing but 2 itself into S3 value. EM, what is that? They said, what is the question for EM? Exactly 2. So E of 2. So E of 2 also same. E2 is equals to S2 minus. Here it will be one number extra. In L, this will be same here, and denominator all will be this minus 1. But in E, how it will be? Both will be increasing now. Suppose we had some extra number, then it will be 4. The next number for of 1 is 2. Here next number is S4, like that it will come, but it's not there. So just substitute the value and write the answers. Okay, same way, how many integers between 1 to 300? So it is 1, same 1, less than equal to n, then less than equal to 300. Oh my god, touchpad is very slow, mouse itself is fast. Okay, then you have to see divisible by at least one of the following. L of 1, L1 you have to do, then at least divisible by none of the following. None of means 5 8 6. We have to take a intersection u. So mod S 300 minus A union B union C you have to do. Okay, then divisible by exactly 2. So E of 2, then divisible by at least 2. So here L of 2. How to find first all these things, S1 S2 S3 is nothing but you have to take one by one. So you have to take 300 divided by 5, 300 divided by 6, 300 divided by 8, one by one value you will write. See here, mod A, sorry, they have written like this, by 5 by 6 C by 8, then 5 into 6 one place they will take, A intersection B, 5 and 6, 5 6 are 30 divided by 36, then A intersection C, 5 into 8, okay, that is 40, then B intersection C, that is 6 8 the 6 8 the 48, sorry, 6 into 8 B intersection C is nothing but, why have they taken 24 here? 6 into 8, it should be 6 into 8 actually. Okay, I don't know why they have taken 24 here, but it should be 6 into 8, which is here by both 6 and 8. I think they have taken LCM, I guess. So 2 3 is a 4 is a, again 2 3 is a 2 is a, then again 2 3 is a 1 is a, 2 2 is a 4, 4 2 is a 8, 8 3 is a 24. Okay, now you understood how this 24 came here, right? Similarly 5 and 6, if you take LCM, 5 into 6 only will come. Okay, now we understood perfectly. I am genius. Then S1 you got, S2 you got, S3 you got, you know the formula, put it and get it. So this done, this does everything done. I don't think I have to see now. Same way, you have this letter bun, pun, that and all that kind of problem I have explained in that model question paper. So I won't be explaining those things here. Now I will directly jump on to which which is this question correspondence. How this correspondence? This is I have done in model paper. I won't explain here again. In how many ways can the integer, see this is also I have done 1 2 3 10 can be arranged in a line, so that okay, this I have not done, so that no even integer is in the natural place. So here for permutation is s equals to 10 factor 1 to 10, how can 10 factorial, so no even number is in natural place. So let a1 be a set of all permutations of the given integers where 2 is in its natural place, where 2 is in natural place. So A2 is a set where all the permutations in which 4 is in natural place. Then so on like that, and so on like that up to 5 is in natural place. What is 5? 2, say 4, 6, 4 is natural place, 6 is in natural place, and 8 is in natural place, 10 is in natural place. That permutations, okay, therefore AI is equals to 9 factorial. Since 2 we are taking out, right? So if you take 2 we are taking out, the remaining things we have to what to say arrange. That's why so if I take 2 out, if I'm taking 2 out here, the remaining 1 to 9 I have to arrange. So that will be 9 factorial. Same way A2, A3, A4, A5 also will be 9 factorial. Then S1 is equal to summation of AI, that is nothing but 5 into 9 factorial, or 5C1 9 factorial. S1 is equal to 5 I have, right? 5 into this 9 factorial. Number of thing A1 also is there, okay, don't forget. A2, A3, A4. A1 we have found already. A1 also is there, don't forget. A1 is equals to A2, A3, A4. How many objects are there? 5 elements are there into what is actually 9 factorial. Similarly, we have to do for AI into AJ. That will be here 8 factorial. How means we are taking 2 and 4 out at a time. 2 and 4 we are taking out. So remaining things is what place 1 to 8 will be left. Number of elements is the 1 to 8 elements. So that's why 8 factorial. Here 5C2 will come. Okay, why 5C2 is because 5 A1, A2, A3 like that. That is I have 5, and then how many this I am taking within a mod. How many are taking 2? I am taking, so 5C2. So same way if I am taking for this particular thing here, A1 I is from 1 to 5, right? So 5 won't change every time. Every it will be 5. If I'm taking AI intersection AJ, then it will be 5C2. If I'm taking AI intersection AJ intersection AK, then 5C3 will come. If I'm taking 4 intersection, then 5C4 will come. If I'm taking 5 intersection, 5C5 will come. Okay, same way you have to required numbers are A1 intersection, A2 intersection, A3 intersection, A4 intersection, A5. Same way they have removed. See, hence S2 is equals to 5C2 into 8 factorial. S is equals to 5C into 7 numbers will be reducing. 5C will be 6 factorial. S5 is equals to this factorial. So what they have asked in the question? No such place. So this won't be in their original place. Okay, so all even numbers are not in original place, so I have to take. So I have found even numbers in arrangement of even numbers in this original place S1, S2, S3, S4, S5. So that is nothing but A1 union A2 union A3 union A4 union A5 union. So I have to take arrangement such that no even numbers in this what to say actually. So I will take the whole union A1 union A2 complement. I will take whole complement, which is nothing but A S0 minus this. Sorry, S0 minus A union B union C union D union like that, A to D union. Okay, like that. So S0 minus S1 plus S2 minus S3 plus S4 minus S5. Just have to find like this. Whatever the number you get, you have to write it off. Same way you can see here how this has done. I won't be solving everything because I just have to explain you how it is done, right? So you can do it. So I'll just skip, 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 skip. Dearrangements. So, okay, so dearrangement is a thing which means suppose n is a, what is dearrangement? A permutation of n number of objects in which none of the object is in original or natural place is known as dearrangement. So suppose I have arranged some objects like this. So what I am doing, 1, 2, 3, 4, 5. Now what I have to, I will write it in such a way that I will write here 2, 3, 4, 5, 1. Now you can see that each number is not in the original place. So that is nothing but dearrangement. Dearrangement is noted d of n is equals to n factor into summation of k is equal to 0 to n minus 1 divided by minus 1 to the power of k divided by k factorial. We can also write as d of n is equals to n factorial into 1 minus 1 by 1 factorial plus, if it is odd number it will have minus before, if it is even number it will have plus before, so on up to minus 1 to the power of n divided by n factorial. That is your actual formula. So we have x e power x equals to 1 by x by 1 factorial plus x square by 2 factorial, x square by 3 factorial, so on up to x power 1 divided by n factorial. When will we use this? When dn is there, right? If they have asked the dearrangement for n greater than or equal to 7, we can use this formula. What is that formula? E power minus 1 is equals to 0 into 0.3679. dn is equals to n factorial into e power minus 1. So this is the formula we can use when n is greater than 7. But remember that if they have asked for more marks, then you cannot use this formula. You have to use this formula itself. Now see here, find the number of dearrangements of 1, 2, 3, 4. List all the dearrangements. So now 1, 2, 3, 4. So what number of n is equals to 4 here. So d4 is equals to 4 factorial into 1 minus 1 by 1 factorial, 1 by 2 factorial, 1 by 3 factorial, up to 4 it will go. Okay. If it is odd, it will have minus before. If it is even, it will have plus before. So 1 by 1 factorial is not 1 by 1, that is 1. So these two things will get cancelled. So remaining I have to find 1 by 2 minus 1 by 6 plus 1 by 24. You have to find like this. Okay. That's it. 24 into 4 factorial is nothing but 24 into, you have to find like that and just write off. The D arrangements are, so you have to, so D4 is equals to 9, and they have asked us to list the D arrangements. So I have to list the D arrangement. Simple, how you can write. So just remember 1, 2, 3, 4. Okay, D arrangement. So I have to write in such a way that this place 1 should not come, this place 2 should not come, this place 3 should not come, this place 4 should not come. So here 9 are there, right? So I can write in such a way that here, see here, 3 will be 3 times, 4 will be 3 times, 1 will be 3 times, 3, 3, 3, that is 9. Okay, in each place I can write, here I can write 2 3 times, here I can write 3 3 times. Simply just what to do, write 2 here, then 3 4, then last I'll write 1. Then what I will do, I'll write 2 3 times, then 3 I have written here, right? Then I cannot write 3 here, except this place I'll write 3 in all the places. Okay, same way you have to list. It's very simple. If you understand, see this, if you understand, it's more than enough. Then how many D arrangements are there for 1 2 3 4 5? So here n is 5. Then how many ways we can arrange the numbers 1 2 3 1 to 10, so that 1 is not in its first place, 2 is not in its second place, and 10 is not in its 10th place. So they are simply saying to do the dearrangement of 1 to 10 numbers. Okay, they are simply here saying to do the dearrangement of 1 to 10 numbers where n is 10. Just do the dearrangement, that's it. Or else you can also take this formula e power x. So e power minus 1 is equals to 1 by so on up to 7 it will go. So e power minus 1, you know that 0.3679. So what I will do here, 10 factorial into e power minus 1 I will do. You can either solve by finding all the values here, or else you can simply multiply like this. Then list all the dearrangements on number 1 2 3 4 5 6, where first 3 numbers are 1 2 3 in some order. Okay, the number of dearrangements of 1 2 3 in some order is d3, and the number of dearrangements of 4 5 6 is d3. Total number of dearrangements given of given numbers where first 3 numbers are 1 2 3 in some order is d3 into d3, which is nothing but d3 square, which is nothing but 2 square, which is equals to 4. How it is 2 square? d3 into d3 we are doing here, d3 square. What is the value of d3 here? The value of dearrangement of 3 is 2 here. If you substitute that d3, 3 factorial into something like that, 1 2 3, some number is d3 into d3 is equals to d3 square. So the value of d3 we are taking as 2 here, it is 4. So the list of such dearrangements are, so see here, here 1 2 3 place, 1 2 3 place I'll substitute. Okay, I'm using 2 times 2 2 times 3. Here also 2 place, so except 2 1 and 3 is, so 2 times 1 2 times 3 will come, and here 3, so here 2 times 1 and 2 times 2 will come, 3 won't come. Same way here I have to find what to say. I think this is already derived. Dn into dn square is nothing but 2 square, I guess. So here 5, 6, 4, 5, 6, right? 4, 5, 6. So here 4 is there. So in this row, I'll have 2 times 5, 2 times 6. In this, I'll have 2 times 4, 2 times 6. In here, except 6, 2 times 5, 2 times 4, like that. Just do the DRMS. So the positive integers 1 to n, there are 11,600 dearrangements where 1 to 5 appear in the first 5 positions. So d5 is equals to 5, okay, what is the value of n? So the number of integers 1 to 5 can be dearranged in the first 5 places in d5 ways. The remaining number, that is n minus 5, can be arranged in dn minus 5 ways. Therefore, the number of DLNs is d5 into d of n minus 5, which is equal to already 11600, which is given. Okay. So now I can take that d n minus 5 is equal to this minus d5. So d5 is very easy to find out, where d5 is nothing but n is equals to 5 here. So you can find the value of that, that is 44. So if you substitute here and subtract, you're getting dn minus 5 is equals to 265. Okay, n minus 5 factorial into e power minus 1. Okay, so we know that d n is equals to n factorial into e power minus 1. So I'm just taking whatever the value place of n is, that n minus 5. So I'll take n minus 5 factorial into e power minus 1, which is equals to this number. We got it. So now what I'll do, I'll n minus 5 factorial into e factorial. So what I'll do, 265 divided by e power minus 1. 265 divided by e power minus 1. So it is e power minus 1. If I take in the numerator, minus 1 will become plus 1. That's why e into 267. N minus 5 factorial is equals to what to say, 720, which is equals to 6 factorial. Okay. Now here what is happening? Here n minus 5 factorial is there. Here 6 factorial is there. Therefore, I can write it in such a way that my n should be such a number, n minus 6, n minus 5 will give me 6. So this factorial is getting cancelled, I guess, or just ignore that. So n minus 5 factorial is equals to 6 factorial. Okay. Therefore, this factorial is equals to, so same. So we can say that from this two equation, I can say here factorial is not getting cancelled. N minus 5 factorial is equals to 6 factorial, right? So I'm equating this number, this should be equal to this number, this. So both are factors. I can say that n minus 5 is equals to 6. So n is equals to minus 5 equals 5 plus 6 plus 5, like that. Then there are 8 letters to 8 distinct people to be placed in 8 different addressed envelopes. Find the number of ways of doing this so that at least one letter goes to the right person. So number of ways the 8 letters in 8 envelopes is, number of ways placing 8 letters in 8 envelopes is 8 factorial. The permutation of 8, that is 8 factorial. The number of ways placing 8 letters in 8 letters such that no letter is in the right envelope, that is D8, dearrangement of 8. Find the number of ways of doing this so that at least one letter goes to the right person. So, okay, now the number of ways of placing 8 letters in 8 envelopes such that at least one letter reaches to the right person is 8 factorial minus d8. Okay, which is nothing but 8 minus 8 factorial into e power minus 1. You will get that value here. So here what I am doing, 8 minus, I am taking 8 factorial common. So 1 minus e to the power of minus 1. So 8 factorial into 1 minus this, you will get 1 minus 0.3698. So you will get here, see what you will get here. 1 is there. So sorry, 1 0 0 0 0. So 10 minus 9 is 1. Okay, something you will get. So here it will be 2. Here it will be 3. Here it will be 2. I think so. This is the actual answer if you fill. So 8 factorial into this number will give you 0 it is. Okay, don't forget. We will get the answer. Not a problem. Each of n student is given a book. The book are to be written and redistributed to the same student. In how many ways can the two distributions can be made so that no student will get the same book in both the distribution? So first time the distribution can be made in n factorial ways. So firstly, it has not received any books. So I can say that n factorial ways we can distribute the books for student. The number of redistributions so that no students get the same book is dn. Number of ways of two distributions such that no student gets the same book again. Same thing here we had to. Here we had taken 8 factorial minus here permutation minus dearrangement. Here we will do permutation into dearrangement. So number of ways of distribution of two distributions such that no students get the same book in both the distribution. So this is one distribution, in this is one distribution. So I have to find the distribution in which in both the distribution it won't get same. So I'll multiply here. Okay. So that is nothing but n factorial into summation of okay same n factorial the whole square into this thing I will do. So this is the set. They have not given the number, right? So I won't write the number. So the formula I have got here. So how many number of books will be there? That much I'll substitute in place of n and find. See, remaining I think if you see here one by one, it's more than enough for you to understand. One of the famous questions, the model paper questions I have solved in model paper itself. So okay, then Rook polynomial. So let us start with one. So Rook polynomial is nothing but r of cn comma x. R of C of n x n comma x is the Rook polynomial for n cross n board is given by R of C of n cross x comma x such that 1 plus n by 1 the whole square into x then plus 2 factorial into n by 2 square into x square plus 3 factorial into n by n3 square. So here only same what is happening. Here square is as it is. 1 will become 2, 3, 4, so on up to n. X is nothing but x. The x will be getting x square, x3, x cube, x power 4, so on up to x power n into 2 factorial. So it is increasing in 2 factorial, 3 factorial, 4 factorial, so on up to n factorial. I'll just leave out that product formula suppose. Okay, so r of c comma x is equals to r of 9 comma x into r of c2 comma okay c1 comma x into r of c2 comma x. Arrangements of forbidden position, so many things are there. I'll just go with for this how to say problem. Consider the board 1 2 3 4. Find the Rook polynomial. Here n is equals to r is equals to 4. Okay, number of rooks 1 2 3 4, that is 4. The position of two non-capturing rooks are 1 comma 4 and 2 comma 3, where r2 is equals to 2. So see here non-capturing rooks, but see 1 I'll take and then I have to write the remaining rook such a way that in that row and that column it should not be there. So that is only 4 is there. Suppose I had like this 5, so it will be 1 comma 5 as well. Okay, understood, right? So I'll erase this. This is not required. Okay, then I can consider 2 if I consider. Okay, if I consider 2, then I have to exclude this and remaining 2 comma 3. So R2 is 2. The board has no position for more than 2 non-capturing rooks. Why? Because if I take this and this, so both this and both rows will go off. So nothing else I have. I don't have any extra term here. So that's why R3 and R4 will become 0. Rook polynomial is R of C comma x equals to 1 plus 4x plus 2x square. Okay, 1 plus how you have got this way, that is nothing but see here n 1 plus nx plus n minus r3. See r3 how many are there? R2. So value of r2. So it's nothing but 1 plus r1x plus r2 r2x square plus r3 x cube, like that will go on if it is there. Suppose now they have given like this 1 2 3 4 5. Here n is equals to r is equal, rooks are 5 rooks are there. So position of two non-capturing rooks are, if I take 1 I will exclude this, that is 1 comma 5. Okay, then eraser. If I consider 2, if I take 2, 2 is there, so 2 comma 4 2 comma 5 I can do. Okay, I'll erase this. Then if I consider 3, I'll take so 3 comma 4. You understand, right? So R1 I have 4. Sorry, R2 I have 4. R1 is 5. R2 I have 4. Then R3. So R3 is equals to R4 is equals to R5 is equals to 0 because 3 non-capturing rooks I cannot take. Why? Because if I am consider array eraser, if I am considering one rook here, okay, then another rook from this number, suppose this, so this whole thing should be excluded. Same way, if I am taking 2, so this whole thing will go off, and if I am taking another from below element, so I won't. So R3, R4, R5 0. So R of c comma x can be written as 1 plus R1x plus R2x square. Okay, I got it. And here you can see here what is the rook and R1 is equal to 7. So non-capturing position, if I consider 1, so 1 comma 4, 1 comma 7, 1 comma 5. If I consider 2, same way if I consider 2, so I can place 2, 3, 2, 5, 2, 6. Okay, then I can consider, if I erase this again, now I can consider 3. So I'm considering 3. So see 3, 2, 3, 5, 3, 7. Okay, 3, 2 I'm not writing. Why? Because 2, 3 is already there. So only I'll write 3, 5, 3, 7. Then I'll erase it. So I can take 4 now. Consider 4. So so 4, 5, 4, 6, 4, 7. I can take 4 comma 7 also here. Can I? Okay, sorry, I cannot take 4, 7 because it is in the same row, right? So only 4, 5 and 4, 6 will come. So remaining you can do the same thing for all the rows. But if you do for 5, 5 can be right 1, 5 comma 1, 5 comma 2, 5 comma 3, 5. But we already have 1 comma 5, 2 comma 5, 3 comma 5 and 4 comma 5. See, 4, 5, 3, 5, 2, 5, 1, 5. So I won't be considering that. So total how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and here that is 10. So R1 is 7 and R2 is 10. Now the positions of 3 non-capturing rooks. So I'll take 1, 4 and 5 I will take. In this I will consider 1. Okay, so this will go. In this I will consider 4 and this I will consider 5. Okay, are 1, 4 and 5. Now see here, sorry, let me erase this. So I have to draw it in such a way. So array, I am considering 1, right? And I'll exclude this. Then 3 non-capturing rooks. So I have to take another rook in such a way that it should not be in the same row and same column. So I'm taking, see, 3 will take. So since I was pairing 1 comma 4 and 1 comma 5, what I will do, I will pair it like 1 comma 4 and 5. 1, 4, 5. And I cannot take 1, 4, 7 because it is falling under the same column. Okay. Then let me erase. Then I'll take for 2, if I am considering 2. So I can take 2, 3 and 5 like that, non-capturing. So it should not be, if I am considering 3, then see, I'll explain to you. First I consider 2. So I cannot take any element from, what to say, this row and this column. Then I'll consider 3. So then I took 3. I should not consider any element in that same row and same column, which is remaining 5. Like that I am writing. Understood, right? I hope you have understood it. Then R4 till R7 will be 0 because I cannot do any non-capturing, 4 non-capturing like that. So I have here R1, R2, R3. So it will be 1 plus R1x, R2 x square, R3 x cube plus done, right? Same way you can see here and do off like this. Now see, find the polynomial for the 2 cross 2 board by using the expansion formula. So 1, 2, 3, 4. Here 4, 2, 3, 4. R d comma x 1 plus x. See, this thing I don't know. I'll say frankly. Find the polynomial. So this thing I'll explain you. So 5 they have taken out, right? So if 5 is gone, then remaining is 1, 7. So if I'm considering 5, so the remaining thing is 1, 3, 5, 7. Here also, if I'm considering 1, remaining is only 4. D is 4 and E is 2, 3, 4. All the elements except 1 is your E. And all the elements except the elements from one row and one column, that is my D, like that. So R of d of x equals to 1 plus x. Okay, for the board E, n is equals to 3, R2 is equals to 1. How means if I consider 2, I can only take 3, 2 comma 3. And if I am considering any other element rather than 2, if I consider 4, all are going out. So only R2 is 1. Okay, that's why for board E, I'll have the polynomial 1 plus 3x plus x square, that's it. Okay, R2, so R1 is 3, R2 is 1. So root function for C comma x equals to x r of d comma x plus r of e comma x. Okay, x into root of d comma x and root of e comma x. So x into root of d comma x is nothing but, see, in d I have r1, only r1 I have, r1 is equals to 1, r2 I don't have, that is 0, right? Nothing is there. So what will that 1 plus r1 square, sorry, r1 into x, this is not r1 square, r1 into x plus r2 x square, right? R2 is 0, so this whole time will go off. So R1 is 1, 1 into x, so 1 plus x, that's why we are getting 1 plus. You understood, right? From this thing you can easily find the root for 3 cross 3 board using the expansion. Since if it is 2 cross 2, you can take any one. If it is 3 cross 3, you take the middle one. So you excluding this, so 1, 3, what to say, 7, 9. So this is my D. Then E will be except by all the terms. So now one by one I will find. For this, what will be the root? So here it will be same as the first equation we had solved here, right? What is that? For this you will get this equation. Where did it go? 1 plus 4x plus 2x you will get for D. Where is D? See, if you see for D, so 1 plus 4x plus 2x for C. Whereas for E, we are not considering this. So first I can take this. So see here, if I am considering 1, so 1 comma 6, 1 comma 8, 1 comma 9 I can take. Okay, same way you have to see. If I are considering 2, so if you are considering 2, 2, 4, 2, 6, 2, 7, 2, 9. Okay, then if I am considering 3, uh, okay, 3, 4, 3, 7, 3, 8. I'll erase. Now I'll consider 4 also once. Like this I'll do. I'll see 4, 2, 4, 3, 4, 8, 4, 9. I think 4 comma 9 is not there, so I'll write off 4 comma 9. Now you can see here R1 is 8, R1 is how many? 1, 2, 3, 4, 5, 6, 7, 8. R2 will be 14. But that's how I have found. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Same way you have to write and find out R3 also. So R1 is 8, R2 is 14, then R3 is only 4. Then R4 so on up to 0. So I'll have 1 plus R1 into x, that is 8x, plus R2 into x square, that is 14 into x square, then R3 into R cube. Okay, R3 into x cube, that is 4 into x cube, like that. Okay, so see here, these things if you see off, I don't think it is required. Okay, like this. Oh man, this is done. So if I say this, what is this? Rook polynomial is done. See, this is one interesting question. This I'll solve in that, what to say, when I'm explaining model question paper 2, that video you can see the remaining answers. So if I remove all these parts, so what is the remaining part which is left? Recursive relation. We can move on to recursive relation directly. Okay, now recursive relation, first order recursive relation. N is equals to C into n minus n plus f of n. You see, I have solved few problems on this recursive relation. You can see that, what to say, in that question paper. This I will do later, okay, because I don't have much time now. So I'll stop here and I'll explain the whatever the part is there in the next video. So till here you can see a few answers I have already solved in that model question paper. I think 2 questions I have solved. You can see that, and right, it is not that difficult. I'll make a video on this if time is there. I'll make anyways. Tonight I will make. Okay. Thank you.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.